Hey guys, chapter 5, notes packet, day 1, page 1. You already watched a video kind of refreshing your memory on functions and how to graph stuff. So now we're adding a little bit of calculus into this situation, okay? We have these things called limits. Limits are a very big deal in calculus. You guys are all going to take calculus next year. It's very important that you have a basic understanding of limits and functions and in order to be successful next year. So they're used to define continuity, derivatives, and integrals. Those three words you probably have never heard before. Maybe you've heard them before, but probably don't know what they are. That is calculus. And think of asymptotes, if you remember, like those dotted lines that the graph gets really, really close to but never touches. That's the same kind of idea as a limit. And so we have this symbol for limit. It looks like this, lim. It's an abbreviation for limit. And underneath this lim abbreviation, it tells you what x is approaching a certain number. And then this minus sign right here means from the left. So think about like looking at a graph, a coordinate plane. The left side is negative numbers and the right side is positive numbers. So that's why negative goes with left, positive goes with right. So the limit of f of x, this is some function, could be like a parabola, or it could be a piecewise function, or it could be a straight line, whatever the function is. What that means is as x approaches c from the left. One thing that you're going to have to be really careful and diligent about for limits is if you remember back to Algebra 2 when you were doing a lot of stuff with like domain and range, I bet you made the mistake more than once when I asked for an x value, you gave a y value or vice versa. You have to be really careful about the difference between x's and y's also in this chapter, okay? So x approaches c from the left. That's what this means in words. X approaches c. C could be like 2 or negative 5, just an x value on the graph. The positive sign means from the right. And if there is no positive or negative, that means you have to look at both the left and the right. So I could be looking at like the function just one-sided from the left or from the right, or if there is not a plus or minus, that means from both directions. If it approaches the same value from both the left and the right, that means the limit exists. We're getting into some really important calculus lingo now. If it approaches a different number from the left and the right, that means it does not exist. Remember that abbreviation DNE? You guys are learning so much calculus already. Oh my God, I'm so excited for you. Okay, what does all of this mean? Allow me to go through an example with a graph so that I can tell you what this means, okay? So if I went too fast, pause, go back, rewind, whatever, copy stuff down, but let's talk about this. Keep in mind that we have this really crazy looking piecewise function. So this is an absolute value, this is a horizontal line, this is just a regular line, this is a parabola, horizontal line. All of that makes up this piecewise function. It's a really weird looking piecewise function, but that's okay. So first of all, what we're going to do is we're just going to review some basic function notation. H of negative 5. Why are they using h? Because they define this function as h of x. And remember, this number in the parentheses is the x value. So I am looking at this graph, which looks super crazy, that has a bunch of different pieces on it, and I am looking at the x value. This is an x value right here, the negative 5. What is the y value? So I'm going to find x equals negative 5. X is negative 5 is right here. Oh my gosh, I have two different options. There's two dots here. One of them's open, one of them's closed. FYI, always use the closed circles. So h of negative 5, it's asking you what is the y value. So this means at x equals negative 5, the y value of the closed circle is 1. Don't use the open circle, use the closed one. 1. Let's try another one. Find the x value of negative 2. So here's negative 2. Oh my God, again, there's two different dots here. There's this one and there's this one. Which one are we supposed to use? The closed one. It's 4. So I wrote a 4. How about find h of 4? That's the way that you read this, by the way. It's not h parentheses 4, it's h of 4. So I'm going to find the x value of 4. It's right here. Got two options. Use the closed one. The y value there is 2. So basically, I give you the x, you give me the y. Okay, so now let's look at this limit thing. Okay, this is weird. I'm getting scared. Limit as x approaches negative 4 from the left. So where's negative 4? Right here. As x is approaching negative 4 from the left. See how this is the left-hand side? Here it's at -5, but it's getting closer and closer and closer and closer and closer to -4. What is the y value? 2. Okay, how about as x approaches -4 from the right? So again, here's -4. And as x is approaching -4 from the right, so now it's at -2, it's at -3, it's getting closer, 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 closer. The limit is 2. Okay, so if I did not ask you for from the left and from the right, since it meets in the same exact place, this side of the roller coaster is coming down to 2, this side of the roller coaster is coming down to 2, that means the limit exists. The answer is 2. So that is why I don't have a plus or a minus here. I had to look at the left, it was 2, and the right, it was 2. Since it is the same value, which is what we wrote up here, that means it exists. That means the answer is 2 from both sides. What happens if I get a different number, or like how would that work? Ooh, let me answer that question when we do 7 and 8. So let's look at approaching -2 from the left. So where's -2? Here it is. As I'm approaching the x value of -2 from the left, I'm getting closer and closer and closer and closer and closer to the x value of -2. The y value there is 4. So again, approaching -2 from the left, think about it like a roller coaster. You're getting really close to the x value of -2. The y value is 4. That's why I got 4 here. What about if I were approaching -2 from the right? So here's -2. There is no right over here, so I have to look at this one. So the roller coaster down here is getting closer and closer and closer and closer and closer to the -2 from the right. The y value is -3. Here's an example where when you look at -2 from the left, we get a certain y value, but when you look at -2 from the right, we get a different y value. These are not the same, therefore the limit as x approaches -2 does not exist. See how I did that here? Because from the left-hand side and from the right-hand side, it approached 2 different numbers. That means the limit as x approaches -2 does not exist. Okay, let's try it again. Let's look at 1 from the left and 1 from the right, and then 1, let's see if it exists. Let's look at these two really quick. So I'm looking at an x value of 1 from the left and from the right. I'm going to try and zoom out a little bit. So here's 1. So as I approach from the left, it looks like the y value is getting closer and closer and closer and closer to -1. As I approach from the right, I'm also getting closer and closer and closer and closer to -1. So since this is -1 from the left and this is -1 from the right, the answer from the left and from the right is -1. The limit exists. You can kind of think about it in terms of if I were like at the board teaching this right now, so use your imagination, and I would use my left hand to glide along where this red dot is going, and at the same time I use my right hand to glide along right here. Do you see how when I get to the x value of 1, my hands would meet? They would meet right there? But if I were using my left hand up at the board to glide along right here, my left hand's way up in the sky, but my right hand is way down like near the floor. My hands would not meet in this case. That means the limit does not exist. When my hands do meet, that means the limit does exist. It exists at that, whatever that y value is. In this case, it was -1. Okay, keep going. How about, let's do 4. Go back up. Sorry, I'm zooming in and out, but as I approach 4, let's see, from the left, so here's my x value of 4. The roller coaster is getting closer and closer and closer and closer and closer to 1. As I'm approaching it from the right, the roller coaster is flat, but it is also approaching 4. Are my hands going to meet? Yes, they're meeting in the same exact place. Even though that's an open circle, they are approaching. Do you agree with me that they are approaching the same exact place? That place is the y value of 1. That is why the limit exists. So don't worry about this dot being up here. That's just a single value. Limits mean what number is it approaching. Okay, so this one is approaching +1. This one is also approaching +1 as I get closer and closer to the x value of 4. Okay, so that is why those down there are all the answers of 1 in this case. So I wrote a couple notes here. It approaches 1 from the left and the right, even though at 4 the closed circle is at a different location. That's okay. That's why the limit exists. We have 1 here and we have 1 here. Let's look at -5 from the left. -5 from the left. There's nothing over here. I don't know where the roller coaster is. I don't know. That's why it does not exist. I could definitely do as it approaches -5 from the right. Looks like it's approaching this y value of 3, but from the left I have no idea. So that's why the direction here is really important. We don't know. The function isn't defined for x is less than -5. This is like the technically politically correct way that you should answer that question, okay? So just keep that in mind. It does not exist, and the reason for that is when you're taking the calculus exam, they're going to want you to write a sentence about this, like at the end of next year. The function isn't defined for any x value less than -5. That is why it does not exist. Okay, it existed again. I told you from the right it did exist, but from the left it did not. Okay, just 2 more questions on this introduction to this limits chapter. What if I didn't give you a graph, but what if I gave you a table? So these tables actually look like kind of confusing and super complicated, whatever, but they're actually pretty easy to read. So the tables work the exact same way. You just have to differentiate the difference between x and y. In this case, find the limit as x approaches 0. It does not tell me from the left or the right, so I need to look at both sides. And what I have here is I can see that my x values here are getting closer and closer and closer and closer to 0. And since these are all negative, this is approaching from the left. 0 would be right here. I'm putting this number where it would belong in the table. And then from this side, it looks like these numbers are also approaching 0 from the right. They're positive. And so that's why moving my way along the table, 0 again is right here. What's happening to the y values? I've got this weird decimal, this weird decimal. You should be able to kind of look at them and be like, huh, it looks like they're getting pretty close to something. It looks like this side is getting really, really close to, well, I don't know, 1.5. This side also looks like it's getting close to 1.5. They are approaching the same number from the left and from the right. 0 falls right here in the middle. Therefore, the limit of f of x as x approaches 0 is, the y value is 1.5. That's the value that it's approaching. So you need to be able to like look at a table and notice anything special with the y value. So same exact thing down here. This is the limit of f of x. I don't know what this graph looks like and I don't really care, but as x approaches 2, it looks like my x values are getting really, really close to 2 here. It looks like I'm approaching from the right here since these numbers are all bigger than 2. And here from the left, it's okay, it's just a t-chart kind of written in backwards order. That doesn't matter. Approaching 2 from the left, approaching 2 from the right. Again, 2 falls right here in the middle. And what's happening to the y values? Can you make an assessment or a judgment in terms of what is it approaching? What is it getting really, really close to? I'm just looking at what's pretty much exactly between this number and this number. It looks like 0.8888. And it is okay to say about. It doesn't have to be an exact number. It might not be able to, you might not be able to tell exactly what the number is. That's okay. But you should be able to make a guess or an estimate. Is the limit exist or does it not? Okay. And so that's how to look at it with a table. That's just a basic introduction, you guys. There's going to be another video tomorrow and then some practice problems. We're going to go very slow through this. But that's your introduction on limits. You're looking at your left hand and your right hand, and are they going to meet or are they not going to meet? And that's whether you answer the question, does the limit exist or does it not? So send your questions to your teacher, and we will have another video tomorrow, like I said, and then we'll do some practice problems the next day. So thanks for watching and have a great rest of your day.